Hi everybody. We're continuing lesson 2, and today now we're going to talk about an important idea: subsets. This is another one of those basic things that one can do with a set. So, what does it mean for a set to be a subset of another? There's the definition, and the definition, I think it has a nice intuitive feel to it. But there are some sort of edge cases, weird things that come along that can lead you astray. So we'll talk about those along the way. So first of all, what is a subset? If you have a set A and a set B, the question is, what does it mean for A to be a subset of B? What it means is that every element of A is in B. Yeah. So if you consider B, you look at all the things in it, if you were to choose just some of them and put them in their own separate set, that would be a subset. If A is a subset of B, we write it like this: A subset equal B. This subset equal is a little bit like less than or equal. Subset, the sort of things to watch out for are when you have the subset idea, there's no insistence that there be more stuff in B than in A. So if A and B happen to be the same set, we would still say that one is a subset of the other. As we're arguing, and when I say arguing, I just mean in the sense of making proofs about, as we're arguing about sets, as we're trying to convince people of things about sets in this class, one of the things that we're going to want to conclude sometimes is when we're going to want to prove that one set is a subset of another. Or alternatively, to show it's not a subset of another. And this is a useful kind of way to hold in your head. If A is not a subset of B, this is what it means for A to not be a subset of B. Yeah. Well, if A is not a subset of B, it means you could find something in A that doesn't come from B. It's like A has something extra in it that's not in B. You can identify an element of A that is not an element of B. And if that's the case, we just write that subset sign with a slash through it. A is not a subset of B. Okay. Those are our definitions. Let's go ahead and talk through this example, and then I'll let you guys go on to the later examples in this section on your own. So example 4, if A is the set 2, 3, 5, B is the set 2, 3, 4, 5, 6, 7, 8, and C is the set 1, 2, 3. First of all, is A a subset of B, and why? Okay, so let's take a look at it. How do we verify that A is a subset of B? Well, we look in the first set, and every element in there we check and make sure that it's an element of the second set. So we go to A, we look at this first element as 2. 2 is an element of A. Is 2 an element of B? Yes, it is. Okay, so far so good. 3 is an element of A. Is 3 an element of B? Yes, it is. Still working on this, but we still have one more to check. 5 is an element of A. Is 5 also an element of B? Yes, it is. So, is A a subset of B? The answer is... Oh, this is going to be too large. Here we go. The answer is yes. And why? Because... what? Every element of A is also an element of B. Okay, so that's A is a subset of B. Okay, now let us consider A and C. Is A a subset of C? So let's double check. 2 is an element of A. Is 2 an element of C? Yes, it is. 3 is an element of A. Is 3 an element of C? Yes, it is. 5 is an element of A. Is 5 an element of C? No, it's not. So we've found something that's in A. It's a member of A, but it's not a member of C, and that means it is not, A is not a subset of C. So, for this one, part 2, we will say, is A a subset of C? No. And what's our reason? Well, our reason is we found an example because... And what was the example? It was 5. 5 is an element of A, but 5 is not an element of C. Boom. So, we would say A is not a subset of C. All right. So we don't have that A is a subset of C. What about the other way around? Is C a subset of A? That's what we're asking in the next one. Well, for this one, we do the same kind of check, but now we have to check everything looking at that subset sign, the thing that comes before it. Every element of this, we need to check and verify that it's in this. So looking in C, C contains 1. Is 1 an element of A? No, it is not. So therefore, we can tell already that C is not a subset of A. So is C a subset of A? No. And why? Well, because we found something that was in the first part, the C. 1 is element of C, but 1 is not an element of A. Cool. Let's talk about number 4 here. Is A a subset of A? Well, we're going to do exactly the same mechanical procedure to check. I discussed this when we talked about the definition, but it's worth seeing how it works really in action when you're verifying. So we're going to look at this, and every element here, we're going to make sure it's also an element here. So let's look at this set A. It contains 2. 2 is an element of A. Is 2 also an element of this set? A. Well, yes, 2 is an element of A, so check. The next one here from this side is 3. 3 is an element of A. Is 3 an element of this side? Yes, it is. And similarly, 5. 5 is an element of the A. Is 5 an element of this side? A. Yes, it is. So the reason is just the same. It's, yes, A is a subset of A because every element of A is also an element of A. It's a little silly, but there you go. Okay. All right. One more, and then I think we're done. So let's see. Do you remember what this symbol means, the 0 with the slash through it? That symbol means empty set. And it's just a shorthand way of writing curly bracket, and then nothing, and then curly bracket. It's a set with nothing inside it. Okay. Is that set a subset of A? Okay, well, how do we check such a thing? We go to this side. We take any element of this side and check, is that element also in here? So when we go to this side, we take any element of it. There are no elements here. So it's like there's nothing to check. Yeah. So I feel like this is not always completely intuitively obvious. When the first one is empty, what is the response supposed to be? But here's a good way to remember it. If we have to answer this question, is empty set a subset of A? We either have to answer yes or no. Okay. If we answer no, this is not a subset of A, well then what does that mean? It means we have to find an element here that is not in here. Right? Every time we answered no, we gave that answer by giving an example, something that was a member of the first set, but not a member of the second set. Now, can we find an element that is an element of the first set and not of the second set? No, we can't, because there aren't any elements to consider in that first set. Okay. So because of that, we're never going to find what we call a counterexample. So we're not going to be able to answer no. Yeah. That means that we got to answer yes, the empty set is a subset of A. Now, there's another way to think through this. We answer yes because every element of the empty set is an element of A. The empty set is easy to check because it doesn't have any elements. There's nothing to check. So it's like it's correct automatically, or it's vacuously true, as they would say maybe in logic. I can write down because, BC for because, well, every element of the empty set is also an element of A. Or I could also write it like this, or I could say we cannot find an element of the first set that's not in the second set. An element of empty set that is not in capital A. That's just another way of saying the same thing. So there's sort of a key takeaway here, and I particularly want to point you guys at these last two observations, because these last two observations are true for any set. For any set A, it is always going to be true that A is a subset of itself. Similarly, for any set A, it is always going to be true that the empty set is a subset of A. In a way, this is the biggest subset of A, possible subset of A, and this is the smallest possible subset of A. That's it for subsets. Go ahead, take a look at the examples below, take a look at the homework problems, and send me your questions.